A few days ago, I posted a video showcasing a water ripples effect achieved through geometry nodes. Today, I will teach you how to recreate this procedural effect without using simulation or dynamic paint. Before we begin, please note that I won't delve too deeply into the process. I aim to be dynamic and swift in presenting the content. If you wish to explore the topics further, I will provide some useful links in the cards. Create a plane and scale it slightly, perhaps around 5 meters. Apply scale and subdivide several times. Rename it to water plane. Now add a simple object, like UV sphere. You can also subdivide it and set the smoothness to the maximum. Create a geometry node for the plane and rename it to Ripple's Proximity. Create a collection and place your sphere inside it. Essentially, all objects in this collection will emit ripples. Drag a collection into the geometry nodes and set it to relative. Create a geometry proximity node and a map range node. Connect the collection node to geometry proximity and geometry proximity to map range. Link the collection input to group input. Then add a realize distance between the collection node and the geometry proximity connection. Connect the map range output to group output. Invert to min and to max. Connect to min to group input and change it from result to color in the node settings. In the geometry nodes modifier, go to output attributes and write color in the result field. Create a material for the water plane and add a color attribute node. In data properties, create a color attribute. Name it color and set its fill colors to black. Select your color attribute in the color attribute node, and you see it in action with the geometry nodes. Essentially, we're using geometry nodes to capture the position information of objects in the collection. Use it in conjunction with the color attribute node to create a mask for our delimited ripple area. Set the to min in the geometry nodes modifier to adjust the mask's opacity around 0.300. In the shaded editor, create a value node with hashtag frame. This makes the value node match the timeline frame. Connect to a mathfied to control the animation speed. Mix it with the color attribute node through a math in add mode and then connect to the vector of a noise texture. Add a math, multiply, and mix it with the color attribute to eliminate the colorful effect. Create a mix RGB node and pull a second connection from the math add to color one. Press Ctrl T on the noise texture to add a texture coordinate and mapping node. The texture coordinate should be an object. Connect the map node's vector output to color 2. The lower the effect value, the less distorted the ripples will be. Add a color ramp after the multiplication to adjust the contrast of the effect. Play around with the color ramp until you achieve the desired appearance. Now that we finished with the ripples, let's create water. Add a mix RGB and set the water ripples color ramp to color 1. Then add a noise texture which will be in color 2. Connect the mix RGB output to the height of a bump node, which will be connected to the normal of the principal BSDF. Now let's delve deeper into the noise texture. You can leave it in 4D and use a value node with a hashtag frame for constant animation in the noise texture. But for this tutorial, let's make the water move in a specific direction. Press Ctrl T on the water noise texture and set the texture coordinates to object. The location is where we define the animation direction. If I simply connect the value node with hashtag frame to the location vector, it will animate all directions simultaneously. So let's use a separate XYZ and then combine XYZ to set specific direction. After this, it's just a matter of adjusting the parameters of the noise texture, mix RGB FAC, and bump nodes to get what you need. Create a mix RGB node and pull a second connection from the color ramp to the FAC. Add a map range and another mix RGB node that you will connect to the emission input. The mix RGB will have black and white colors, where black is essentially zero emission and white is the color of our phone. Set color 1 of the mix RGB before the map range to black. Connect a noise texture to color 2. Set the noise texture to 4D and connect a value node with hashtag frame, using a pair of math divides for animation speed adjustments. Then, adjust the parameters of the noise texture to your liking. Pull a third connection from the color attribute node to a color ramp. Add a math multiply and an invert color. Finally, create a mix RGB node and connect the invert output to the FAC. Connect the mix RGB node's output to the base color of the principal BSDF. You can use both color slots to simulate depth or dirt under the objects. That's essentially it for today's video. Feel free to play with the color ramp, math nodes, and other parameters to see what you can achieve. Thanks for watching, and we'll see you next time.